Hello, I'm Stéphane Farou, and I'd like to talk to you about the usage of the date data type with SQL. Let me tell you that dates are great. They can be nicely formatted, they can record events that took place before January the 1st, 1970, perhaps you don't mind but I do, and the DBMS can control if the dates you enter are valid. Besides, you have a lot of functions to perform data arithmetic. In some cases, you can have simple calendar dates, and sometimes you add to the date the time of the day. Some products have different but close date and datetime types. Some products, such as Oracle, have a single date type that includes the time. It is very common to see dates poorly used in queries. Suppose, for instance, that we want to write a query that returns the sales of this month. Most often, developers will write conditions that will look like this example. That is, that they will extract from the date some elements, in that case the year and the month, and will compare them to the very same elements extracted from the current date, in effect removing the day of the month from the equation. Depending on the product, the syntax may vary, but the principle remains the same. I have used here an ANSI syntax that should be understood by most products. If you are using the datetime type, you will have the same type of issue. If you want to list, for instance, today's events, you must remove the time from the equation. You can use function extract as before, or you can use proprietary functions that are sometimes simpler, such as Oracle's trunc or Postgres's date trunc. When applied to date, they will in effect set the time to 0 hours, 0 minutes and 0 seconds. It works, as far as it gives the good result, but it works usually inefficiently. Why? If the date column is indexed, and if you write your query in the way I have just shown, the DBMS will not use the index. If you haven't seen it yet, you may be interested by another of my videos that you'll find here, and which explains the basics and some subtleties of indexing. Basically, the problem we have at hand is that in an index, all entries are sorted by key value. You use the key to locate the addresses of the rows that contain this particular value. Somehow, it's like using the name and the address to find the right phone number in the phone book. If you base your search on some extraction from the date, it's like asking to find the phone numbers of all the people that live in Main Street. You will have no other solution than reading the phone book from cover to cover. You might think with some products of a solution, which is to also index the result of the application of the function to the column. It's not as smart as it looks. Adding indexes adds overhead to insert and delete operations, and actually, if you write your query cleverly, you can use the existing index without any need for a new one. The idea is to use a range condition. What is a range condition? Well, if we represent time like this, and if we write down there the current moment, if you want to get the data for this month, what you really want is the data between the first day of the month and the last day of the month, because it isn't impossible that some rows may refer to data in the future. Therefore, the range we want is really bounded by those two dates, the first and the last day in the month. Getting the first day in the month is usually easy. You can rebuild the date by extracting the year and month and setting the day to 1. Very often, you also have functions to make life easier, such as, once again, Oracle's trunc function that also knows with the right parameters how to make all the dates in a month the same as the first at 0 hours, 0 minutes and 0 seconds. Getting the date of the last day in the month may be a little more tricky. Some products provide functions, but with all products, the simplest way to proceed is probably to add 1 month to the current date. With Oracle, you have the addMonth function. With SQL Server, you use dateAdd. You have a slightly different dateAdd with MySQL, and with Postgres, you simply say that you add an interval of 1 month. In all cases, you will get something that I will call sometime next month. From there, saying that the sale date belongs to the same month as the current month is the same as saying that the sale date is greater than or equal to the first of the current month and strictly lesser than the first of next month, which I obtain by applying the same function to same time next month as I apply to the current date in this Oracle example. Instead of extracting what you want from each and every row, you will compute the bounds of the interval only once. Almost all conditions on dates can be resolved to range conditions. What will be the benefit? Since you will compare a date to a range of dates, the DBMS will be able to use any index that exists. But you will gain more than using indexes. Perhaps you consider an SQL query as a single operation that funnels the data you want. In most cases, the DBMS will see your query not as a single step, but as a succession of steps that feed each other. The role of the optimizer will be to decide in which order to apply various operations that will take you from what your tables contain to the results that you want. It will have to weigh the various options and choose what is likely to be fastest. The cardinality of operations, that is, very crudely, how many rows we are dealing with at each step, is a key factor in determining how fast we can hope to get the final result. When you compare the result of the extract function to another result of the extract function, there is no way for the DBMS to guess the cardinality. With a range condition, it is in a better position because it usually knows the extreme values and can guess the percentage that the range represents. This brings us to a second issue that you often encounter with dates. Suppose that we have 2 years' worth of data in our database. We have a temporal scope that is defined by the extreme values, say 2 years ago and yesterday. A problem occurs when you have to store, for instance, an unknown expiry date. Using null is a solution, but when unknown expiry date means current value and is an important search criterion, using null is a bad idea, especially when you are using a product such as Oracle that doesn't index null values. Many developers prefer using a fixed date that is very, very far away in the future. But then, look at what happens for the DBMS. Instead of having dates that are spread over 2 years, if you use December the 31st, 3999 as the dummy date, the optimizer suddenly discovers that the database contains dates that are spread not over 2 years, but over 2000 years. And if you want to query half your database, it may decide that 1 year is a very tiny part of the whole and decide to use an index when it shouldn't. Since there is no data for most of the time interval, you might think that collecting frequency histograms that tell how data is distributed might be helpful. The problem is that histograms may be very precise when you have a limited number of distinct values, but when you have values that are much more continuous, in practice when you have more than about 250 distinct values, it is no longer possible to count how many times each particular value occurs, and the DBMS will resort to different tactics. For instance, it will try to associate a similar number of rows to a fixed number of buckets. Then, it will record the values at the bucket boundaries. Since about the same number of rows are associated with each bucket, if the difference between two boundaries is small, you have a dense area and popular values. Conversely, a big gap between two boundaries means a sparsely populated range. It is very similar to level curves in maps. When lines are close, the slope is steep, and when they are far apart, the slope is very gentle. You can understand that with this type of histogram, faraway values can still fool the optimizer. What can you do then? It's great to have a long-term vision, but in the case of SQL, it can backfire. What I would suggest, if you need to use dummy dates in the future, is to use dates that are comfortably in the future but not that far in the future. In most cases, using dates that are towards the end of the century will bring the same benefit as dates towards the end of the millennium with fewer risks of completely fooling the optimizer. Thank you for your attention.